Hey everyone, this is 1-3, and we've already talked about our types of data. So we're collecting quantitative data, qualitative data. Now let's look at the different ways to collect the data. So this first little bit, read through that. It's just kind of talking about the key concepts for today. So the first thing we're going to look at really is this gold standard idea. The best way to collect your data is to have a placebo and a treatment group, right? And this group doesn't get anything. Let me move that down under my face. And this group gets, like a sugar pill, and then this one gets the actual drug. That is the gold standard. It's a random sample. People don't know what's happening to them, if they have the real drug or not, and that kind of thing. So that's our gold standard idea of collecting data. But we always are referring back to random. We want our data to be collected randomly, the best way we can. So we have two types of collecting data. It's either an experiment or an observation. Experiment, you're actually giving them a treatment. You're doing something to them, and then you're writing down your results. Observational study, you're doing nothing to them. You're just so you're not modifying them all, you're just writing down characteristics from them. So for an experiment, I might be actually giving people a medication. For an observational study, I might be writing down how many people take business calculus or something like that, okay? An example, so observational study, here's my example. Observational study, past data to conclude, observe past data to conclude that ice cream causes drownings, okay? Based on the data showing that increased ice cream sales are associated with increased drownings. The mistake is, oh wait, I don't want to talk about the mistake quite yet, right? So what's wrong with saying ice cream sales are associated with drownings? We observe this. Well, we eat more ice cream in the summer and we swim more in the summer, right? So of course, they're not really related. They just both happen at the same time. So the mistake is to miss the lurking variable of temperature, okay? And failure to see that the temperature increases, then both ice cream and drownings increase. If you miss something so big like that in your study, you could be promoting something that's not really true. Okay, so experiment. I'm going to do an experiment with one group treated with ice cream while another group gets no ice cream. We would see the rate of drowning victims is about the same in both groups. Excuse me. So the ice cream didn't have an effect. So if I really want to do an experiment, I give these people ice cream. Sorry, you don't get any. And then y'all go swimming and see who drowns, right? So that's the idea of the experiment. And clearly here, the experiment would be better than the observation. That's not always the way it is. A lot of good observational studies happen, but an experiment, you actually do it. Okay, when you're designing your experiment, you could be having replication, okay? So is where you, well, replication is where you repeat an experiment on more than one individual. So when I want you to get out of the idea of replication is, well, or I guess in general, when I am designing my study and I am collecting my data, I need a lot of data. I need as many people as I can. When you do a study with so little people, it isn't really going to be meaningful. Okay, so replication requires sample sizes that are large enough so that we can see effects of treatment. So replication, you need a big sample size, right? Because would you want to take a medication like, all right, I got cancer again, and I'm going to take this pill to fix my cancer. But they've only tested it on 2 people. Hopefully it works for you. I mean, maybe it's the last draw, but I would really like a lot more people, right, to prove that this is something I should be doing. Okay, blinding is a technique that you use like the placebo, right? So you have untreated subjects. Well, okay, so blinding and double blind are a little different. Blinding is where you got treated subjects, right? And you have not treated subjects. And then we observe or whatever to see if the treatment actually helps. But in the blinding, you know who has it and you don't, and who doesn't. In a double blind, no one knows. So it's all picked at random. You don't know if the person you're talking to right now had the placebo or if they had the actual during the experiment. So blind and double blind. Randomization is just that idea that everyone's randomly picked. Okay, so we really want everyone to have the same chance to be in the survey or the study that you're doing. Okay, so all of this that we're talking about is so many definitions. I get that. So you can definitely use notes. But the big takeaway from all of this is really, I can have an observational study, an experiment, replication is good. We have this idea of blind studies. It's and the more sample size, the bigger the sample size, the better. You want more people, okay? And we would like them to be random. So we would like them to be in this random world. And the ways to get a random sample. So there's one, 2, 3, 4 ways to get our random sample. Nope, 6. Okay, so 6 ways to get our random sample. So look at the first one. What is a simple random sample? Simple random sample. Okay. It is a sample of n subjects. We always use n for how many data in how many subjects, right? Our sample size, how many data we have. It is selected in in such a way that every possibility, I can't even read. I'm all done. In such a way that every possible sample of the same size n has the same chance to be chosen. So we're just like, okay, it's simple random. Everybody has a chance to be chosen, and we're going to randomly choose you. A simple random sample is often called a random sample, but strictly speaking, a random sample has the weaker requirement that all members of the population have the same chance of being selected. So simple random has this extra piece, and then this piece here is just all random samples. So the simple random is selected in such a way that every possible sample of the same sample size has the same chance of being chosen. So I pick a sample, and I pick another sample. They have all the same chance to be chosen. It's kind of weird wording. Okay, systematic to me is easier to look at. Systematic. Select from a starting point, and then you just pick every so many. So this is every third, a little car example. Systematic. You line up everyone in your population, and you take every third person. Used to be like you take out the phone book, yeah, you circle every third person, right? Or something like that. There's not really phone books anymore. Okay, convenience sampling, by far what you'll probably have to do for our projects and things. Use data that are very easy to get, right? I'm going to stand outside of Walmart and ask people questions. This is a convenience study. Not everyone in the town has equal chance. Not everyone goes to Walmart, right? It's convenience. So if I'm trying to prove that we need, what's something controversial? We need another bar at a certain area in Sheridan County or Sheridan area, right? And I go outside of a very packed bar and I ask people if we should add another bar. they're all drinking and they're all already at the bar and it's a full bar. So my sample I'm collecting is probably skewed in my own way, right? It's because most of those people are frequent bars. It's a full bar, so they're going to want you to open another bar. If I go to outside of, let's say, a very strict church that doesn't believe in drinking, then ask them if they think there should be another bar. You're going to get a different result, right? That's convenience. Think through that one. It's very convenient, but is it really giving you a good sample? Okay, stratified. Stratified is where you subdivide the population. Okay, maybe you do like this one's just men and women, but you subdivide into at least two groups and then you draw samples from those subdivisions. And it could be like you're subdividing the town into subdivisions and then you're randomly picking one of those subdivisions and then randomly picking people out of that or something like that. But you subdivide the main group and then pick a subgroup. That's stratified. Okay, there's my little diagram. I have men and women, and then I picked so many people from men and so many people from women, and this happens to be 3. But okay, cluster sampling. You divide the population into sections, clusters, then randomly select a cluster, and then choose all the members in that cluster. So you're splitting everybody up, and you're going to say, okay, I'm taking that cluster and everybody in it, that cluster and everybody in it. Somewhat similar to stratified, but you start with subgroups on stratified. And this one, you divide the population area. Okay, so this one's more of like a map. Think of it as a map. Okay, multi-stage. You use a bunch of them. I could do 2, right? I could stratify them, and then I could do the systematic, like I could break them into men and women and then take every third one. So I'm doing like a little bit of both. Okay. All right. So
hopefully my microphone will change. This just died. It's a super convenient time. Okay, so then we have observational studies. So everything we just went through are ways to collect random samples. So when I have an observational study where I'm not modifying, I'm just observing, right? I can do cross-sectional study, right? The cross-sectional study here. And the data are observed, measured, and collected at one point in time and not over a point in time. Cut it, just think of right now. What is happening right now? Collect that data. And I'm going to observe it. Okay. Observational study could be retrospective. You collect everything from the past. So what did this business have happen last year? I am going to observe what had happened and then do a study of that, collect that data. Prospective is data that are collected in the future from groups sharing common factors. So sometimes called cohorts, right? So this study is of the future. Like I'm going to study this cohort as they go through college and see, what happens or something like that. So confounding. So we're looking at errors for the rest of this little bit here. So I'm really going to just skip. You can read the other little rigorous control, but we're going to just skip down to errors, right? No matter how well you plan and execute your sample collection, right? There is going to be errors always. So sampling errors you could have an error that's in your way that you sample, right? There could be a discretionary between the sample result and the true population. So you collected a sample and you figured out that like 70% of those people had girls, it could just be your sample. It doesn't really mean the true population of people has more girls than boys, right? So you have to be careful that when I collect a sample, there can be errors. Okay. And human error could be like data entry wrong, computing errors, questions with biased wording, false data by respondents. So when you collect data, weights, totally. When I collect data of weights, how many people are going to lie? Oh, I will. I'm not telling you the truth. If you get off the scale, well, then I guess I'm telling the truth. So when you collect data for your first project, you should, at the best you can, collect it yourself. Not get it from the web, not get it from their word of mouth, collect it yourself. Put them on that scale, see what they weigh. Okay. So that's human error. And the sample was not random is really common as well. I was lazy. I walked over to Walmart and I collected data from the first 20 people. It's kind of random because, but it's not a good random sample. Okay. So, all right. So this has got a lot of wordy stuff. The big takeaway for today is the different ways to collect your data to try to get random, right? And that I could be doing an experiment or an observation. So I could be doing an experiment or an observation. There it goes. It's kind of scrolling there. Experiment or an observation. And the types of ways to collect our sample. Those are really what I want you to think about, and errors. That's always big. All right. Talk to you soon.